Good morning. It's Wednesday, March 25th, and these are your notes for today. We're going to revisit properties of logs, part 2, aka use logs to solve exponential equations. So first thing we need to talk about is the common log, and you've heard me use that phrase before. The common log is a logarithm with base 10. And generally, you'll see that log pop up where they don't even give you an explicit base. They'll just give you log of 100 equals 2. And I told you before that if you're given a logarithm without an explicit base, you assume that base is 10, aka called the common log. So if we're given log base 10 of 100 equals 2, we know we can rewrite that as the exponential equation base 10 exponent 2 equals 100, which is true. 10 squared equals 100. So for the common log, they don't even write the base. They just assume that you know without an explicit base. We're talking about base 10. The common log is really helpful when we're solving exponential equations that aren't obvious. So just to review a little bit, when we first were introduced to exponential equations, 27 to the x equals 9 to the 2x minus 1, we know that in order to solve for x, in order to set these exponents equal to each other, we would have to first start by rewriting our equations so that they have the same base. So I asked myself, 27 and 9, can they be rewritten with the same base? And they can. 3 cubed is 27, so I can substitute 27 for 3 cubed on the left. And 3 squared is 9, so I can substitute 9 for 3 squared on the right. And then I can use my exponent rules to solve. So I multiply 3 times x and 2 times 2x minus 1. Don't forget to distribute there to solve for x. Okay, so common log comes into play when that type of work is not so obvious. So for example, we're given 3 to the x power equals 11. Well, 3 squared is 9, 3 cubed is 27, so x is going to be somewhere between 2 and 3, but I have absolutely no idea what it is. So I'm going to take the common log on both sides. And you're absolutely allowed to do that. It's kind of like taking the square root on both sides or the square on both sides. We're just going to apply the common log on both sides. And basic rule of algebra, whatever you do to the left, you do the same thing to the right here. But now that I've taken the common log, I can use the properties of logarithms to take that exponent and move it out front. We know that if you have a log of an argument raised to a power, that power can move out front and become a coefficient. So now it reads x times the log of 3 equals the log of 11. And now to isolate x, I can divide both sides by log 3. So x is going to be equal to the common log of 11 divided by the common log of 3. If you've noticed on your calculator, you do have a log button, but it is only the common log. It's no coincidence that they printed base 10 to the x power right above it. That's because this log button is the common log. It's the log with a base 10. But we can use that button to solve our equation here. We can find common log of 11 over common log of 3. Make sure that you close your parentheses around the 11 to show that these are two separate logs that we are finding the quotient of. X is equal to 2.18. Okay, and I'm going to double check how close my answer is by plugging in x into my original equation here. It says 3 to the 2.18 power should be about 11, and we get 10.96 it is. Okay, example 2. We're given 9 to the z minus 4. My dog is crawling in my lap. Hello, Hazel. Hard to write with a dog in your lap. 6.28. Okay, so this is another one where the answer is not obvious. 9 to the first power is 9, so this number is going to have to be smaller than 1, or the power is going to have to be smaller than 1, but it's not something I can figure out just off the top of my head. So I'm going to take the common log on both sides. And when I take the common log on both sides, I can move that z minus 4 out to the front of my log like a coefficient. But remember that z minus 4 is its own quantity, so I'm going to use parentheses there to make sure that we know, keep this z minus 4 together. So I'm going to divide both sides by log 9. And z minus 4 will be equal to the common log of 6.28 over the common log of 9. Plug that in my calculator. 0.84. Okay, add 4 to both sides. Z is equal to 4.84. Okay, sorry, I'm off the screen a little bit. I'm going to plug that in just to see how close my approximation is. So I'm going to take 9 to the 4.84 minus 4, and it should be about 6.28 and 6.3, so pretty close. Obviously, the more decimal points you use, the more accurate your final answer is. I think 2 decimal points is plenty for this purpose. Okay, so next property we're going to talk about, next and last for today, is called the change of base formula. And the change of base formula allows us to take any log and rewrite it as a common log. So if we're given log base b of a, then a log of any base with an argument is equal to the common log of the argument divided by the common log of the base. Always argument over base. So for example, we're given log base 5 of 12. Well, we don't have a button in our calculator to evaluate a base 5. We only have, Hazel, come here. We only have common log. We only have base 10. So I can convert this into the common log by taking the common log of the argument, 12, over the common log of the base, 5, and get that approximation here. Log base 12 over log base 5 is 1.54. So just to see how close you are, rewrite your log as an exponential equation where your base is 5, your exponent's 1.54, and let's see how close we are to 12. 5 to the 1.54 power is 11.9, pretty close. Okay, last one for today. You're given log base 3 of 8. And once again, you do not have the ability to find base 3 in your calculator. You only have one log, and it's the common log, base 10. So we're going to use the change of base formula to convert this into a common log by taking the common log of the argument over the common log of the base. And it's always argument over base, think alphabetical order, A over B. So log base 8 over log base 3 is about 1.9. Okay, so if you take 3 to the 1.9 power, you should get 8. That makes sense, right? 3 squared is 9, so it would make sense that 3 to the a little less than square, 1.9, would give you close to 9. Yep, 8.06. Okay, your homework is up on Classroom. That's it for today. Tomorrow we will cover the natural log, and then believe it or not, we are actually done with this unit. Good luck.